Hello 8th graders and happy Friday. Yesterday we dilated figures about a point. Today we're going to dilate figures about the origin. You're going to do a great job. Let's dive right in. Let's start with our do now. Rectangles HJKL and H'J', K'L' are shown on the coordinate grid. Are the two rectangles congruent? Yes, these two rectangles are the result of rigid transformations of one another. Which sequence of transformations would map HJKL to H'J', K'L'? The correct answer is C. If I rotated the figure 90 degrees clockwise and then reflected it over the x-axis, I would get the resulting figure H'J', K'L'. The figure shows two parallel lines cut by a transversal. Angle 1 is 64 degrees. Go ahead and find angles 2, 3, and 4. Remember that vertical angles are equivalent and angles on a straight line are supplementary. They add up to 180 degrees. Angle 3 is 64 degrees. It's vertical to angle 1, so it's equivalent. Angle 2 and angle 4 are both on a straight line with angle 1, so I can subtract 180 minus 64. The result is 116 degrees. Use what you know and what you know about corresponding angles to find angles 5, 6, 7, and 8. Angle 5 corresponds to angle 1, so it's 64 degrees. Angle 6 corresponds to angle 2, so it's 116 degrees. Angle 7 corresponds to angle 3, so it's 64 degrees as well. And angle 8 corresponds to angle 4. It's 116 degrees. Now let's do a couple division questions. What's 6 divided by 5? Write your answer as an improper fraction. 6 divided by 5 is 6/5. What's 1/6 divided by 5? Well, 1/6 divided by 5 is the same as 1/6 times 1/5. What's 1/6 times 1/5? It's 1/30. Now let's simplify the fractions. What's the largest number that I can divide both 4 and 16 by? 4. When I divide both by 4, what is that fraction written in simplest form? It's 1/4. What is the largest number I can divide both 10 and 24 by? It's 2. When I divide both by 2, what's my fraction in simplest form? It's 5/12. What's the largest number I can divide both 16 and 12 by? It's 4. When I divide both by 4, what's my fraction written in simplest form? It's 4/3. Now let's jump into our new content of the day. A dilation creates a scaled copy of an original figure. The scale factor is the number that each side is multiplied by. And when drawing a dilation, the distance of each point in a figure from the center of dilation is multiplied by the scale factor. Each point moves away from the center of dilation. Let's look at an example. Today we're going to make dilations that are centered at the origin. The origin is the point 0, 0 on the coordinate grid. Graph the image of the quadrilateral after a dilation with scale factor of 4 centered at the origin. When this happens, I know that each point is going to expand in distance from the point 0, 0 along straight lines. I also know that the scale factor is 4. Because the origin is at 0, 0, I can multiply each coordinate of the ordered pairs of each point by 4 to find the ordered pairs for the new figure. Let's look at R. R is located at 1, 0. To get to R prime, I'm going to multiply both of those coordinates by 4. 1 times 4 is 4. 0 times 4 is 0. So r prime is located at 4, 0. Now let's do point S. Point S is located at 0, 1. S prime will be 4 times that distance from the origin. So I can multiply 0 times 4 is 0, and 1 times 4 is 4. S prime will be at 0, 4. Now let's do T. T is located at -2, 0. T prime will be located 4 times as far away from the origin. What's 4 times -2? It's -8. 4 times 0 is 0. So T prime will be located at -8, 0. Now let's do Q. Q is located at 0, -1. So Q prime is located 4 times as far away. 0 times 4 is 0. -1 times 4 is -4. I can graph Q prime at 0, -4. Now that I have all of my points, I can connect them to make my dilated shape. Because I'm dilating about the origin, I can just multiply each ordered pair by the scale factor to find the ordered pairs of the vertices of my new shape. Graph the image of the rectangle after a dilation with a scale factor of 3 and center at the origin. First, let's find the original ordered pairs. What's the location of A, B, C, and D? A is located at -2, -2. B is located at 2, -2. C is located at 2, 1. And D is located at -2, 1. Now let's find the ordered pairs for our dilated shape. I know that the scale factor is 3, so A prime will be 3 times as far away from the origin. I can multiply -2 times 3. What's -2 times 3? It's -6. Now I can do the y-coordinate. What's -2 times 3? It's -6. So A prime will be located at -6, -6. Make sure that's drawn on your paper now. What would be the ordered pair of B prime if I multiplied both the x and y coordinate by 3? It would be at 6, -6. What would be the ordered pair of C prime if I multiplied both the x and y coordinate by 3? It would be at 6, 3. What would be the ordered pair for D prime if I multiplied both the x and y coordinate by 3? It would be at -6, 3. Now I can connect my vertices to draw my dilated shape. So, to dilate a shape about the origin, I can multiply each coordinate by my scale factor. Now let's try with a reduction. First, write the original ordered pairs for points U, S, and T. U is at -5, 5, S is at -5, -5, and T is at 0, -5. To find the ordered pairs for my dilated shape, I need to multiply each coordinate by the scale factor. What's -5 times 1/5? Remember, -5 times 1/5 means the same thing as -5 divided by 5. It's -1. What's 5 times 1/5? Remember, 5 times 1/5 means the same thing as 5 divided by 5. It's 1. So U prime will be at -1, 1. What would be the new ordered pair for S prime? Well, negative 5 times 1/5 is negative 1, and negative 5 times 1/5 is negative 1. So it would be at negative 1, negative 1. What would be the new ordered pair for T? Remember to multiply each coordinate by the scale factor. Well, 0 times 1/5 is 0. Negative 5 times 1/5 is negative 1. So it would be at 0, negative 1. Then I could connect my points to make my dilated shape. Try another. Draw the dilation of the square with a scale factor of 1/2 and a center of the origin. First, find the original ordered pairs. Point M is at 10, 10. Point N is at negative 10, 10. Point K is at negative 10, negative 10. And point L is at 10, negative 10. To find point N prime, I can multiply each coordinate by the scale factor of 1/2. What's 10 times 1/2? Remember, it's the same as 10 divided by 2. It's 5, so the x-coordinate for M prime is 5. The y-coordinate is also 5. So I can graph M prime at 5, 5. What would be the new ordered pair for N prime? Well, negative 10 times 1/2 is negative 5. 10 times 1/2 is 5. So N prime would be at negative 5, 5. What would be the new ordered pair for K prime? Well, negative 10 times 1/2 is negative 5. Negative 10 times 1/2 is negative 5. So K prime could be graphed at negative 5, negative 5. What would be the new ordered pair for L prime? Well, 10 times 1/2 is 5. Negative 10 times 1/2 is negative 5. So L prime could be graphed at 5, negative 5. Now I can connect my vertices to make my dilated shape. Let's do one more together, then you can try 3 on your own. First, find the original coordinates for the quadrilateral that we're going to dilate with a scale factor of 3 and center at the origin. What are the original ordered pairs? To find the new ordered pairs, I can multiply each coordinate times the scale factor. What's negative 2 times 3? It's negative 6. What's 1 times 3? It's 3. So N prime can be drawn at negative 6, 3. I can see how N has expanded in a straight line from the origin. What will the ordered pair for K prime be if I multiply both of my coordinates by the scale factor of 3? It will be negative 6, negative 6. I can graph K prime at negative 6, negative 6. I can also see how K prime is an expansion along a straight line from the origin. How would I graph L prime? What would the new ordered pair be? It would be 0, negative 6. So I can graph L prime at 0, negative 6. I can see how L expanded away from the origin. What would the new ordered pair be for M prime? It would be 6, 3. So I can graph it at 6, 3. I can see how it expanded in a straight line from the origin. Now I can connect the dots to make my new shape. Now you try a few. First, what are the original ordered pairs for FEG? F is at 2, 2. E is at 2, 0. G is at 1, -1. Now, draw the dilation with a scale factor of 3 and center at the origin. Enter the new ordered pairs into the boxes and draw the dilation on your paper. Check your work with mine. Did you draw a dilation that was correct? Let's do 2 more. Draw the dilation of the quadrilateral with a scale factor of 1/2 and a center at the origin. First, what are the original ordered pairs for this quadrilateral? A is at -6, -10. B is at -2, -10. C is at 8, 6. D is at 4, 6. Now, find the new ordered pairs and enter them in the boxes, and draw the dilation of the figure. Check your work with mine. Your shape should look like the one that I've drawn on the screen. Now let's do one last problem. Graph the image of the quadrilateral after a dilation with a scale factor of 3 and center of the origin. First, enter the original ordered pairs in the boxes. K is at -2, -2. L is at -1, -2. M is at -1, 2. And N is at -2, 2. Now, graph the image after the dilation with the scale factor of 3. Enter the new ordered pairs in the boxes and graph the image on your paper. Check your work with mine. You've done a great job on this video. Now go to IXL Practice Q.2.